So today, as I promised yesterday, because it's Wednesday, we're doing a Mustang 2000. We did a Mustang 1000 yesterday. And this has come with a bodged together power lead. And I think the customer's asked me if we've got a scrap set we can pinch one off. Well, I'm sure we have. So I'll look amongst the tat later on. But I think we have only got one. So it's a Mustang 2000, and so you gain tone and RF gain. And you get TX and RX lights, and you get a channel 9 switch. Wow, that's what I've always wanted. Not. It would be much more useful to put the 10 decibel attenuator on the front, because that's really useful when you're in a convoy and you don't want to blow the windows out of the car behind. So we've ordered replacement ballast resistors because I'm hoping this doesn't need one, because there's a possibility the ones we like to use are on order. RS, I ordered from RS, and RS came back with order cancelled, discontinued, and I did order some from CPC. I ordered 25 and they got 3 in stock and the rest to follow. Now I wonder whether those others will never follow. So take the top lid off. Not sure what that's about. Take the bottom speaker lid off. So the protection diode is blown, and they've bodged the protection diode on the bottom. So we'll be putting in, oh dear, and it's had the ballast resistor totally removed. Not good news at all. Right. Well, we'll power it up. Well, the only saving grace here is the wire on this is so thin, you'd be hard pushed to put more than 1 amp through it. Now, my experience is that when the ballast resistor has been removed, the radio has then been used, then the PA is destroyed, and they're very expensive because those Mitsubishi 2166s were discontinued 20 years ago. So I think there's some Eliflow ones which are genuine-ish for about 12 quid a piece. But all those ones you see on eBay with nice shiny cases are fake, because you can't have a 20-year-old device that's got a nice shiny set of leads. They're all going to be tarnished at 20 years. And I've bought them, I've been caught out, and the things develop about 1.5 watts. So, switch on the power supply, make sure current limit's in place. I'm going to drop the voltage to 12.6 just in case the fact the ballast resistor is missing is going to distress it if it's still working. We'll select picture in picture, and we'll actually select the correct camera. Then from yesterday's old Bible reading, we put the we put the notes for the Mustang 1000 on here, so we'll do exactly the same. So for a start we need ballast resistor. Don't know whether I can recover that diode and protection diode. So switch the radio on, and we're in PA. No display. Okay, so we've got no display. And if we looked at that, the radio's doing 5.5 watts. I'm going to put the power supply to 13.8, and just for a moment we'll see what power it's doing. .2 watts. So that's no good at all. I'm going to switch to low power so we don't put the PA under strain. Oh, well, at least it's still working. And in low power we're getting 300 milliwatts, which is fair enough. Now I'll do the deviation with us. I don't even know what channel we're on. 27.63125. So let's see whether we can 6, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Somewhere about there. Look at that. We're on channel 20. I counted them up well. Well, oh, it's got the Roger bleep still working, which is fine. So we'll look at the deviation. Wallow. Deviation is 4 kilohertz, which is no good at all. So that's no good. Frequency, I'll move the camera over. Well, this has had the screwdriver expert in it, hasn't it? .2779141. So that's wrong. We'll sort that now. Most of these are now struggling to come onto frequency, and this is well beyond. So I don't know whether the crystal's been changed or what, but we need to just pop that down. Or perhaps I think higher frequency makes it louder. There we go, just slightly high so it's got room to drop, which is what they do. So that's that done. And then we'll look at receive and see where we are with the signal generator. Plug in the test instrument, find out which socket it is, its extension speakers there. Mind you, at least they've screwed the chock block onto the back panel. I've seen worse bodgers. So we're on the cyanide meter. I've got no switch on thumb. Okay, RF gain was down. So it's receiving. It sounds a bit. Why has it gone off? Hopefully that just wants cleaning. So let's look at where we are with this cyanide. Well, despite its screwdriverness, it's not too bad. It does sound pretty awful. It's waving around. So when it's feeling happy, it's doing 0.41 microvolts, and when it's feeling unhappy, It's doing 0.5 microvolts. It's feeling happy at the moment. 0.45. We'll attribute 0.45 microvolts to it. Should do better than that. Now, yesterday's we had to change that capacitor. We don't have to today. So my best thing to do, I think, is we'll start by putting the ballast resistor in, and then we'll just come back to the video after I've done that. Okay, so go back to the power meter because we've gone back to transmit. We've done the ballast resistor. I have run out of the correct number of ohms. We'll put in a slightly lower one, which we sometimes have to do because not all the PAs develop 4 watts with the preferred value. So we actually have a selection, and we'll see how this goes. So let's see what happens. I'm not going to touch the tuning. Oh, I might do because it's been fiddled with, hasn't it? But I'll tell you what we'll start with, and that's the VCO. So we'll go to channel 1. I've just cleaned the channel 9 switch and the displays come on. So because I did one of these yesterday, I've remembered it's a floating chassis, so we can just pop that to our power supply earth, put that to there, look for the far side of capacitor 9, select channel 1, should be 2 volts, that's fine, but we'll just take it that little bit lower with T1. And then we're going to transmit wherever the microphone's gone. Turn the volume down. Going to transmit, monitoring capacitor 9, 2.11. Just pop a bit down on that trimmer. You know, there was a time when every one of these came in with this way out, but these days they're not doing, so I don't know what's happened. So on channel 40, they think it should be 4.5, but I actually think it should be anything over 3. 3.7, 3.28, we're in lock, so it's going to work on all 40 channels. If you don't do that, you can end up with channels disappearing after 31, or channels disappearing after 8 downwards. So that's not got stupidly hot, and the radio is drawing 1.4 amps, which is higher than I would expect. So what power we're getting out of it, I've not been looking. 3.5 watts. It's a bit better. So we'll just go through the tuning of the PA, or the transmit, shall I say. Tell you what, the frequency's dropped, so things are warming up here. So at 3.6 watts with a warm radio. We'll check this one with the spectrum analyzer because it's been messed with. So I'll just put that on. So we've got 4 watts. with the ballast resistor I've selected, it's capable of about 4.3. Well, thank goodness it didn't kill it. I just can only assume that the radio wasn't used very much after it had been modified. And of course, we're back to this. So although it was doing, that's the wrong piece of paper. Although it was doing 6.2 watts, it doesn't mean that it was doing that on 27 megs, does it? Well, if I've read that on my test set, it means it was doing it between 24 and 33. So let's look at the spectrum analyzer. I'll just press auto and see whether we've got enough signal. I'll just clamp that on there and leave that there so it's loosely coupled. Press auto. But I didn't press auto, I pressed the wrong button. So there's our fundamental frequency. And now we'll put in 54 megs and look at the second harmonic. So program 54 megs. We've got a second harmonic. And it's reading... Well, actually shows 111 megs. So we need to lose that. I don't really want aeroplanes listening. Actually, there's nothing there on 54 megs. Are we... Oh, it's there. Ooh, minus 36 too high. So let's see what we can do. I'm just wondering if any of these coils have been messed with, like that one. So that's now minus 54, so that's just acceptable, which is fine. Hopefully 111's gone. I will just check that. Yeah, 111's totally gone. So that coil had been messed with. I'm glad I checked that. So if we now go, I've turned the spectrum analyzer off, we now go back to the power meter on the test equipment. It's doing 4.05 watts. I'm not going to change it from there. It's a little higher on channel 1, it's 4.1 watts. But I think we're safest to leave it as it is. There's only 0.1 watt in it across the 40 channels. So, we'll better just calibrate the S meter, or the RF meter, which is there, to correspond with what we've just set with the power. So, in fact, it's hardly needed adjusting, so that's the centre of the red zone. Strawberry patch. Now we'll do that deviation because that was ridiculous. It's not like AM where louder is better. Just pop that down. See where that is. Wallow. One. It's just very slightly high. 2.6. Wallow. That's spot on. Peak there's about 2.4. Right, so that's covered the transmitter. So we'll look at the receiver. I'm going to spray some service oil into this. I don't know whether it's faulty, or if it's faulty I don't know what we're going to do. Can't exactly order from Cybernet, seeing as they stopped doing CBs 20 odd years ago. They make solar panels instead. Just try and work that in and see whether that... Okay, well, we've got some kind of connection there. So we'll start by putting the oscilloscope on, turn the bench light off, switch to the oscilloscope, put an S9 equivalent signal on, and we'll tune the detector for peak. I've got a sneaky suspicion it is out. I'll tell you what, I'm wrong. I wonder if the IFs are out. I'll just do those. Yeah, that was out a bit. Now we'll go for the front end. Put the cyanide meter on. Bench light back. There's a lot of capacitive. If I put my hand in, look how that changes so dramatically. Is this a set we've got to put the bottom on because of capacitive effect? Oh well, it's tuned up alright. So that's more or less 12. I'll just put it a bit more on 12. I would say that's fair and squarely on 12. Show you the attenuator. So we're at 0.3 there, and we're at 0.3 there. So we're on the border. I'll just adjust this for the next scale up. We've got 0.32. You could say it's 0. I'm going to say it's 0.315. So it's not quite as sensitive as yesterday's, but of course it's beyond what its manufacturer says it does. And of course it differs from set to set. So that's done that. Now let's look at the squelch, because that's what is always a mess on these sets. So put the squelch to full. I want that to come in at 100 microvolts, so we'll put that on the signal generator. No. So that needs adjusting till it comes in, which is there. So that was too strong. So now we'll do the opposite. We've parked the signal generator at 0.3 microvolts. We'll turn the squelch to minimum, set it to threshold, see when it comes in. It comes in straight away like yesterday's did, and it's coming in it's coming in at 0.32 microvolts. Yep, and it's leaving at 0.17 microvolts. So that's a fine spread. So that's fine. The other thing I'm going to check is if we turn the signal generator off, turn the squelch down, unplug the aerial from the radio. I've taken it from the test equipment. I'm going to switch the radio off. I'm going to switch it back on again. Yes, it does hiss, because these can mute when there's no aerial connected, and then people don't think the set's working. So that is great. So that's everything tuned up. So now it's physical stuff, and I'm going to, before taking this apart, I'll see if we've actually got a set which is scrap and still has its connector. Now I know there's very, very sadly a Mustang 3000 in my scrap pile here, and we bought it like that because we certainly wouldn't scrap. I'd move heaven and earth to make a Mustang 3000 work, but we bought it as a scrap chassis, and it had already been well robbed. See what we've got under my bench, because some of the more used scrap chassis are lurking around here. Some sets which were really nice once. It's usually the silly modification people that wreck them. Nah, I can't see it. Right, we'll look in one of the sheds outside and just see what tap we've got kicking around. Well, it's not good news on the connector front. I've brought 68 18-litre boxes out of storage, and all our scrap chassis have had them pinched, I think mainly before we bought the scrap chassis. I've contacted 3 of my associates up and down the country who do CB radio repairs, and one thinks he may. So what we're going to have to do is not be able to do that. What we will do is we'll set the S meter. So we'll now put S9 on the signal generator, which I've done. And now the plugs come out. Then we'll adjust the S meter to S9. It was a bit generous, wasn't it, there? So all that's left to do, I just want to spray some of these switches and controls. They're a bit dirty. And we'll put that diode in the right place. So I've got the diode now in the right place. That's the one that we've taken out. I can't really do anything but throw it away because the leads were too short to use it, but what are they, 5p? So we'll get the isopropyl alcohol out, and I just need to get rid of the flux where I've been soldering, which is there. Put a link in where the track was originally missing from the diode failing before in the past. For some reason there's also some nastiness just there. Get rid of that. For some reason there's some soldering around the synthesizer chip, so we'll deal with that. And then I've had the soldering iron to do that ballast resistor. Bit of soldering there. Okay. Now, in the next few days, between now and when this radio is due to go back, of course, we could end up with getting a socket for this set, so we'll revisit it if that's the case. But otherwise, there is nothing I can do. I think what's happened is when these power leads dried up 25 years ago, when the people came up against a set with no power lead, the socket just got ripped out and wires got shoved in. So whereas you've got the Cybernet sets and the leads are still manufactured, you've got the Uniden sets with the 3-pin lead and they're still manufactured. We've got the tooling and moulding to do the Maxcom ones. So it's just left these, which are a bit of a difficulty. If I knew who made the mouldings and whether they still did, I'd be quite happy to buy the tooling to do it. But there we are. Can't wait for the radio rally season to be out. You never know what's in a junk box. So, just need to clean these controls. There we go, that's it. So we're done. So just a quick final test. And check the power things transmitting. Whoops, wrong mode. Whoops, 4.5 when it's cold. I can hear the Roger Bleep working. So what have we done? Cleaned the controls, done the ballast resistor, done the protection diode down there in the proper place, not on the back of the board. Have to leave this as it is because we can't put a socket in. I've been through everything and it's all working a treat. So that's a Mustang 2000. I found our scrap user's t-shirt to wipe the fingerprints off the front. I found our scrap chassis, as I said, and there's no socket on that, and I found all the other sockets because I brought them out of store from the radios which we have lurking. And we said yesterday that green was negative. And we'll find out whether this speaker works. We'll unplug our extension speaker. Socket's a bit, still a bit iffy at the back. But it's a lot better than it was. I've tightened it up a bit and I've cleaned it. It's not a dry joint. Just had a lot of wear. That said, we'll go over the soldering. I've just been looking at the scrap 3000 we've got. And all I can see on the face of it that you gain with the 3000 is a delta tune control. So the Mustang 1000 was originally $69.99 if I remember right, and the 2000 was $79.99, and the 3000 was $89.99. So I think that's what your extra tenor got you. Mind you, it's a lot wider set as well. So if you've got a thing about wide sets, well, that was your boy. Alright, put the screws in it, and then when Mr. Chippy's available, we're doing on the air test. And as I said when we were writing down the cyanide figures, it's not quite as sensitive as yesterday's. There's always a tolerance from one set to another. You don't see that many 2000s, let alone 3000s. I don't know whether many of you have noticed that every integrated circuit, every microchip in these sets is Sanyo. So it's not mix and match and Billy No makes, everything is Sanyo. Well, normally with the Cybernet 134, you've got the Toshiba audio IC, and then you've got the Sanyo synthesizer. Do you have a Toko chip in there as well? Some other ones. Right, switch on. We're on the aerial. We're on 19. Check RF gains up. 19 Roger. Channel 9 switch now works. Go over to PA and we come back to which was another problem. So there we are, ready for the on the air test. So it'd be nice if I can just get a power connector in off a scrap set between now and the next few days, so we don't have to send this back like this. Thank you for watching the Mustang CB2000 from 1981. He agrees. Anyway, them aside, tomorrow it's the Mustang 3000. Thanks for watching.